we handle the guy with the smallest d value, which is s, right? So when we handle s, so now this has a d value of 1, right? Because we know about this path to it. And this has a d value of 40 because we know about this path to it, right? So now what node do we handle next? We handle A. And when we handle A, what's going to change? This one's going to change a d value to 31, and this one's going to change to 3. Right? So that there happened. And now what do we do next? It's this 3 that's next. Right? So when we handle it,
Shouldn't be C. Shouldn't be C next?
C next? No, because C has a d value of 31.
Oh.
Right? We get the one that we think these are the numbers which are how close is this, do we believe this node is to S? And we grab the one who's closest. Right? Now, let's look at the coloring here. Black edges, meaning these are the edges to the handled nodes. Right? So this node has been handled, and yes, this is in fact the shortest path to A. And these edges, these orange edges, are our parents in the shortest path that we know about so far. Right? The shortest path that we know of to F is this 1 followed by this 3. Right? So now when we update, when we handle this guy, who gets updated? Right? This gets updated to 3 plus 1. Right? And this guy gets updated to 3 plus 15. Right? Gives you 18, which is better than this. Right? So if we see if this thing works again. I think we've lost our batteries. This hasn't worked in a while, has it? Maybe we need new batteries or something. Let's carry the keyboard around. Alright, so we're going to handle that guy. And when we handle that guy, this gets updated to 18. And this gets updated to 4. Right? You'll notice that this used to be orange because that was the path. But now we updated the pi. The pi of this node comes down to here because this gives us the shortest. If you follow these edges backwards, it'll give you the shortest path that we know about so far, which is of length 18. So who do we update next? Right? This is the smallest guy. So we update that one, and this gets updated to 4 plus 6. Right? And this is going to be 4 plus 1 is 5, which is better than the 18. Right? So we go to there, and then the 5 gets happened, which brings this down here. And then I think we're doing the 7.
6.
Oh, nope, then we go back to the 6. Right? And the 6 updated this one. Right? People kind of following this? And then we just keep going. And we're done. Oh, and then here, what gets updated next, even though there's not connected, this is the next smallest value, right? So we can update that, and this gets updated to infinity plus 3, which is still infinity, and we're good. Everybody follow that? So these are our loop invariants that we want to maintain, right? Remember, the loop invariant is that for the handled guys, we have the length of the d. The d is the length of the shortest overall path. And for the unhandled ones, the d is the shortest path of those paths that have been handled. And we want to maintain this. And so our algorithm, we want to make progress while maintaining the loop invariant. And the way we make progress is we handle the node with the smallest d value. Right? And now we want to prove that we maintain the loop invariant. Right? We have to prove that the node which we've handled, right? If it's becoming handled, u used to be over here, We're handling it, u's moving over here. Right? In order to move it over here and maintain the loop invariant, we have to maintain, we're not changing the value of du, so we have to prove that it is in fact the length of the shortest path. And we don't want to spend too much time on this because, quite frankly, it's never going to be on a test. But here's a little proof that it's the shortest path. All right? So, see, there's all these handled paths, and u is the guy who has the shortest, is not handled. Right? This is the set of handled nodes, right? And u is not handled, and the du gives you the length of the shortest handled path to here. And we're now handling it, and we want to prove that this is the shortest overall path. How do we prove it? Is, well, consider some other weird path to u. Right? Well, we know that du gives you the length of the shortest path to u. Right? That's kind of what we said already. And we know, and so we look at, as I said, we look at some potentially shorter path, and then follow that path until you get to the first node that's not handled. Right? So that what we're trying to prove, this is the guy with the smallest d value, right? We want to prove that this is the shortest path to u. So how do you do it? Consider any other path to u, and we want to prove that this path is no shorter. Right? It could be the same length or it could be longer, but it's no shorter. And how do we do that? Well, start from S, follow this path until you get to the first handled node. All right? And what do we know? We know that this first unhandled node. This unhandled node, what's the length of this shortest of this path here? This length up to here, which we call path u prime, it's got to be let's forget these arrows, but let's keep going in these various ones here. I'm confusing everybody here. All right, so how do we know that this guy's v values is how do they compare? Right, why does this one have to be smaller or equal to this one? It's because we chose this one, right? How do we know that the path from here to here is smaller than the length of this entire path? Smaller or equal to? The subpath and?
Weights can't be negative.
Weights can't be negative. Right? Good. Everybody got that? That's where we use weights can't be negative. This path has to be shorter or equal to the length of this path because these weights can't be negative. And how do we know that du is less than or equal to the length of this path? It's because this is a handled path, right? Right? Because it's going through handled nodes, and this is the first unhandled node. So this is a handled path, and by definition, du prime is the length of the shortest handled path to u prime. So we have all these pieces, and that gives us that du is less than or equal to the length of this path. People kind of follow that? It's a little tricky, but don't worry about it too much. All right, so now when we handled u, right? But when we handled u, we updated, we handled all u's neighbors. So we updated the dv's. Right? When we handled u, we looked at the edge from u to v, and we updated v. So now we have to make sure that that dv is still the length of the shortest path, shortest handled path. And it's the same kind of thing, is right? We found now that u is handled, right? It's a handled path. So this is now a handled path, and we're considering, we compare this length to that length. All right. That was, you probably were confused by that, but don't worry about it too much. All right, so here, what's the running time of this algorithm? All right, the running time is for every edge, in the graph, you have to handle it possibly twice. If it's undirected, you handle it in both directions, right? But if it's directed, you only handle it once. So every edge gets handled once. And when you handle an edge, what do you have to do? Is it constant time to handle an edge?
To update the values of every no.
Yeah, for each edge you have to, right? So if we're handling this edge, right? We update this d value, right? For every edge, we have to update this d value. And what do we have to do to update this d value that takes work? Right? We have to compare it. We have to compare the old d value to this, right? Does that take much work? No, that's a constant work. So is there any work there? We have to update the priority queue. Remember that we have this heap, and if this d value changes, then it has to bubble up in the priority queue, right? So each update like this, we must update the priority queue, and updating the priority queue takes log n time. So that's why this algorithm takes the number of edges times log n time, right? Which is pretty good. And that's it for Dijkstra's algorithm. Any question about Dijkstra's algorithm? Let's find an eraser. So I'm going to give you a question that I have put on every midterm since the beginning of time. And I might not put it on this midterm because I have another good question for this midterm. Maybe it'll go on this good midterm anyway. All right, so suppose this is S, and I have an edge here of length 5. All right, so here's a quick question. Suppose what am I doing? There's a question. Everybody think about this. Suppose I first handled this guy, right? So this is the guy that's the only guy who's handled, right? What's the d value of each node? Everybody think about it. Don't shout out the answer. Think. What's the d value of this node? What's the d value of this node? What's the d value of this node?